All right, so we're continuing with the inverse. So last day we were looking, or last video, we were looking at the branches. So now we know the left branch is the under branch, right? And then the right branch, it goes bigger, so that's why it's above, right? So the x values are getting bigger, so that's why the y values are going up. And that works whether or not, and I showed you here on the side, right? So as the x values go left, that's why the y values go under. The x values are left, and if the x values are bigger, that's why the y values go up. So that's why. So the right branch is the upper part of the square root. The left branch is the under part of a square root. So that looks like it's a positive square root, and that's the negative. Okay, so then we've got that. So this is the visual idea. So algebraically, we're going to use that visual in order to do this algebraically. So we're here now. So now we've got algebraically, we are looking at this. Is this the whole parabola, whole quadratic, or half? One of the branches of the parabola. Whole or half? How do we know? Contrast. Is this one whole or half? And then look at what this one has. This is whole because there's no restriction here, right? So it's not saying anything. This one says x is less than or equal to 3. So that means this would be the left branch. Right? Less than would be the left side of the parabola. So left branch, less than from the vertex. Does that make sense? So what we're looking at is this one, nothing, right? It's just the parabola, the whole parabola, what we did in grade 10. The whole parabola. This one here, because of this statement here, as soon as you see this, that is telling you it's one of the two branches. So this would be the whole thing. So when we take the inverse of this, we're going to have the whole inverse. So it's going to, the whole thing will tip over. Okay? This means it's only one of the branches, which means when we have the inverse, it'll be one branch. It'll be the left or the right. So if it's left, it'll be the under part of the square root part, right? So under part. All right, so that's what we're looking for. So this here, when I have the full quadratic, okay, so let's talk about this again. If I have the full quadratic, when I do the inverse of a whole quadratic, so look here, if I do the inverse of a whole quadratic, is the inverse a function? No, because the vertical line test. When I'm looking up and down, I'm going to hit more than one spot if I was to do a vertical line test. The vertical line test means you're taking your eye and you're looking at it up and down, drawing invisible lines going, no, I hit it twice. My new relation here is not a function. How about if I have a branch? If I have a branch, so this is the left branch of the parabola, when I take the inverse, I'm going to get the under part of the square root function. Is my new square root here, is that a function? Yes, because when you do a vertical line test, I'm only going to hit that blue line once. Okay? So when I have a branch, the inverse is a function. When I do not have a branch, when I have the whole thing, when I take the inverse, it's not going to be a function because it's going to hit more than once. Okay? So that's interesting to know. We're going to use that at the end. So let's first do all of this algebraically. I'll show you the contrast between the two. This is the whole one, whole parabola, right? Nothing, no restriction here. This is the one of the branches. If it's less than, it's the left. If it's greater than, right, if it's open towards the x, it's the right. Does that make sense? So left because it's less than. So less than. Less than means left. The greater than would mean the right. Okay, always, always. Okay, so let's solve these guys here. So the first one here, the first step would be to switch this to y. So switch that to y, like that. So step 1 is we're still doing the same step as we did before, so switch f of x to y, right? So that's step 1. Step 2 is to switch x and the y. So we're actually going to switch the x and the y. So this now is x, and this is y. So you're literally just switching the x and the y. Everything around it is still the same. Just the letters switch, right? Just the variable switch. So I physically switch the y to an x and the x to a y. Everything around it stays the same. Okay, and then step 3 would be to solve for y. It's the same steps we did before. You don't have to write this, but just so you know, right? The same steps that we did before from when we did the linear inverse, but we're going to add something to it. So there's always a but, right? There's always a but. We have to add something to it because it's quadratic. So let's solve. So to isolate the y, always start from the outside in. This is the term with the y, right? I want to start from the outside. Anything around it here, this is attached, so I want to start from the outside and move towards the y. So let's get rid of this 2. So let's get rid of this one here to the other side. Okay, so we're going to leave this. So x, that becomes plus 2 equals 5, and we're still trying to isolate the y squared. Okay, so I'm going to highlight that. This is what I'm trying to isolate here. So work from the outside in. So this is the y squared. We're isolating that guy there. Let's get rid of the 5 next. Do not square root yet. We're going from the outside further towards the y. So look, the furthest out was the negative 2, became a positive 2. Now let's move further in. The 5 is outside of the y squared. The little y, we'll do that last. The little square, do that last. Don't square root it yet. I want to get rid of the 5 next. Okay, so see how I'm moving outside in, right? You can't square root it first. Nope. You got to take the negative 2, bring it over. Now I want to get rid of this big 5 out here, so take the 5 away from both sides. You can put it all over 5 or each one. It's the same thing. Okay, that cancels this one, makes it 1. So then I've got here, I'm going to rewrite that again, so it'll be x plus 2 over 5 equals y squared. So see how I'm moving further in to the y squared. So outside the negative 2, then to the 5, and now just to the y with a tiny squared. Now you can square root. Okay, you can't do these in opposite order. It's basically opposite bedmess order. You're actually doing the bedmess backwards, but I always think of it as outside in. So go from the furthest out, 5, and then now the 2. Okay, so the 2, in order to get rid of the 2, we need to do the square root. So when you're going from a squared to a square root, we know we must do plus minus. So square to square root. So if I'm going to square root both sides, you have to put the plus minus there. You must put it right away that you know it's plus minus. If you skip it on this step but add it to the next step, I'm still going to lose half mark here because right away it's plus minus. You can't just add it onto your answer. You have to say when it happened. This is where it happened. So this cancels this out, and you're left with the y. And this here, this has to go from, I'm going to point this out, okay? This has to go from the bottom to the top. It's the whole thing. Some people do this really messy, so I'm going to write this down. So I'm going to say not, okay, not this. Okay, it's the square root of the whole side, right? So not just the top part, it's the whole thing. It has to go right to the bottom. Okay, and I'm square rooting the whole side, not just the top, not just the numerator. Okay, that's wrong. Even if it's a little longer, it has to go right to the bottom of the 5, please. Okay, right to the bottom of the 5. Grab the whole thing, grab the whole side. So see how it's 5? I want to grab the whole thing. Okay, and then that's it. So we stop there, and that's beautiful. So y is going to be the positive negative square root. And remember, the positive negative square root is this. It's the positive square root and the negative square root. That's what gives you a sideways parabola. So sideways parabola is made up of a positive square root with a negative root, right? The positive, and this is what I mean by positive. People are like, what do you mean by positive? Positive in front of it and the negative in front of it. It's a vertical reflection. Okay, so it's always made, and then this one's more complicated because it's been stretched and everything. Yes?
How would you graph it or visualize?
You can graph it easily. So this one is back to our graphing, right? So usually I would push it in front like this. So to graph it, right, it's that. That means it's a horizontal stretch times 5. So if you wanted to do your chart, it'd be 5x, and then move it left 2, so minus 2. And I have nothing happening with the y, so y stays y. Right? And that's it. And then here, the negative means that I'm going to do one graph for the negative y, which means it's the under part, right? Under part with the negative y. And I'm going to do the same chart with the positive y, and that will get me the upper part. So it's two square root functions, yeah. Right? So one of them is the negative square root function here, and then the other one's the positive. So you would do two tables, right? So you'd say, okay, but one of them is positive y, so that would be the top part, and the other one's the negative. So it actually splits into two equations, one for the positive, one for the negative. Yeah, right? So, and that's what a sideways parabola is. It's made up of two square root functions. Does that make sense? Right? So the positive one would be this chart, and the negative one would be this chart, and so one's upside down of the other. Okay, so it's actually two square root functions stuck together, and that's what makes up a sideways parabola. Okay, so you got to make sure you grab the whole thing, right? So because otherwise that 5 is not a horizontal stretch, it's a vertical stretch, right? You know the difference now. So that's why I'm not just being picky for neatness, it's accuracy. I want the whole side grabbed. So then it's a horizontal translation, horizontal stretch by a factor of 5, not a vertical, right? And you know it makes a difference now, right? So it's not about neatness, it's about accuracy. Okay, so we've got our two graphs. I'm not asking you to graph it now, I just want you to stop. Now, this is not a function, right? So it's not a function because it's positive, negative, and you know you've got the top and the bottom. Okay, we're going to do it again. I'm going to show you what to do when it's a branch, right? So what do we do? How do we do this question differently if it's a branch? You're going to start the same way. Okay, you're going to start the same way. And it's a branch though, right? So switch the f of x to y. So we'll do the same first step. So y is negative 2 x minus 3 squared plus 5. Switch your x and y, just the letters, right? So then everything else around it is the same. So all I did is switch the two letters, x and the y switched around. Okay? And then now isolate. So step 3 is solve. When I'm solving, I'm working from, look, my y is here, right? So y is inside. I'm working from the outside, furthest outside, inside. Okay, so furthest out would be 5, right? So we're going to bring the 5 over first. Okay, so from outside in, always outside in. So we're going to go x plus 5 becomes minus 5. Okay, then what's the next one on the outside that we're going to do? Yes, this one, not yet here, right? This square rooting comes after the divide by 2, not before. Okay, after. So I want you to get rid of the negative 2. So starting from outside, then I'll move to the 2, the squared here, but not yet. So do this part first. Okay. So this next step, this negative, we taught you way back in grade 9, and we want the same habit. We don't leave the negative in the denominator of a fraction. So I want you to divide the negative in. So this divide the negative in, I'm going to grab this guy here. I'm going to use, actually, blue. Okay, so I'm going to grab this one and divide it into both. Right, we're dividing the negative into both. We never leave a negative in the denominator. We've been doing that since grade 9. So divide the negative, that'll make it negative x plus 5 over 2. This cancels to be 1. Okay, so clean that up. Now, I still want the y, right? We're moving from the outside in, so this is the y is my goal. Now I can do the 2 up here. After I get rid of the number in front. Has to be the number in front, then the 2 out here. Has to be that order. Some people try to do the 2 out here, then the number. No, this one's first, then the square root. Okay, it makes a totally different answer otherwise. Okay, now you're going to square root it. And when you square root, you grab the whole side, top to bottom, plus minus. The whole thing. That cancels this guy out. Okay, square and the square root cancel. So now we're positive, negative. Negative x plus 5 over 2 equals y minus 3. Almost there. You can skip some steps if you're comfortable, but don't skip until you're very, very comfortable. Okay, then the 3 is my last thing to go. So I'm trying to get to y. So now the last one to move is going to be the 3. So this one moves over, it becomes plus 3. So we're going to get positive or negative, negative x plus 5 over 2. That becomes plus 3 equals y. Do you notice that it's stopped here? The 3 is not in the root. It's after it. That's your vertical translation. Which way? If it's plus 3 at the end, vertical translation, 3 up. Right? So don't put it in the square root. That's my vertical, so it comes in after. Okay, that's beautiful the way it is, but it's wrong. It's not finished yet. It's only wrong because it's not finished yet. So the steps are all good. Now, one more time. Let's look at these graphs. If you have a full parabola, right? Have a full parabola. When you take the inverse of it, you're going to get the positive negative. That makes sense. If you have a full parabola, you get the positive negative, right? And we have the different graphs of the parabola. So if you have a positive, you're going to get both sides, right? Make sense? If I have one branch of the parabola, the left branch, I should only get one side of the square root. If it's left, it's the negative root, right? It's the reflected one. If it's positive, it's the top one. Okay? Does that make sense? So if it's the full parabola, I'm going to get top and bottom. If it's one branch, I should get one. This is the full parabola, yes? Full parabola. This is the left branch. I only want one of these guys. I don't want the top and bottom. This is giving me top and bottom. Sorry, top and bottom, sorry. Okay? I don't want the top and the bottom. What do I want? If it's the left branch, do I want top or bottom of the square root? Bottom. Left is bottom. That's it. Does that make sense? Because it's going to the left, the numbers are smaller. That's why the y values are going smaller. To the left, the x is getting smaller. When you inverse it, that means the y's are going under. So if it's the left branch, then I want you to take this guy here. So let's grab this. I'm going to grab it with a bright color here. So this left branch, I want you to go to the answer. So all the way up to here, it's beautiful. So you'll want to give you marks all the way up to there. Then if it's one branch, you have to make sure you do a therefore at the end and summarize that I only want left means under, right? So left is the under part. So I want therefore, you don't have to put the therefore, but I like to remind myself what I'm doing. Therefore, it's going to be, so it's left. If it's left, you want the under, which is the negative. Okay, the under part, which is the negative. So I want you to write it this way. You're going to go, therefore, I want the negative part of my answer. So not positive, negative. You're going to do this. Okay, one more thing to bring us back to when we did the inverse of a linear. On the side, I want you to state this properly. Now let's go back one more time. If I have a full parabola, is the inverse a function? No, because you get the positive, negative. If I have one branch, is the inverse a function? Yes. So if I branched it and I took one, I'm allowed to use our fancy schmancy, remember this notation? So this notation here, because now it's back to being a function. So I want to, okay, this part here, because I only took one branch, it's a function. So we will be marking that. Either we give it 1 mark or half a mark, but we're checking to see if when you get a branch, you go back to this notation. That tells you it's still a function. And remember, I said you do that when it's a matching set. So f of x becomes inverse f of x. They're both functions. So it's a matching set. How come I didn't do it here again? That's a function. Is this a function? No, because it's got top and bottom. It's this. So I didn't match it because I didn't break it up. So f of x becomes just a y. Stop there. Stop. Right? So stop there. This one, because it's a branch, I always want you to picture dragging it and saying, ah, now I can fix my answer. So branches need to be fixed, right, when it's a function to a function. So that's the one. Okay, so this is worth either a mark or half a mark. It depends on what we decide, but still, you don't want to waste that. So whenever you do a branch, you have to decide. So this is for a branch. When you get a branch, I want you to take a look at that. Okay? Any questions? Okay, that's it. Next page, I'll stop.